14 THIEE Control and System Graduates Research Colloquium, EXC 2023. Biometric authentication utilizing EEG based on a smartphone's 3D touchscreen sensor. The authors, Mrs. Cecile Yasser Yunus, Drive, Mosha Blazem Shuwandi. Presented by Mrs. Cecile Yasser Yunus.
Outline. 1. Introduction. 2. Objectives. 3. Study map. 4. Methods. 5. Show video how signal recording of the EEG. 6. Results and discussion. Final state. 7. Conclusion.
Introduction. Motivation. These mechanisms have numerous security flaws and are vulnerable to attacks including shoulder surfing. Electroencephalography EEG signals are one of a kind. This fact can be used to overcome the shortcomings of currently used methods. These signals can be captured and sent via wireless channels to be processed. In this research we present a novel security system for mobile devices that combines the 3D touch authentication offered by 3D TPT with EEG signals. The authentication credentials based on 3D patterns are considered identification tokens. We have considered using EEG signals captured during a 3-level pattern drawing over the smartphone screen as part of the authentication procedure to do so. Introduction. Motivation. The system's security was tested by simulating 25 unsuccessful attempts by 5 malicious users to break in using the same methods as 5 legitimate users. A hidden Markov model. Models. EEG signal SAND. A support vector machine SVM. Binary classifier verifies test pattern reliability. The DETH-RAND ROC curves are security matrices used to evaluate verification systems. Findings suggest this method has potential as an alternative to developing sophisticated authentication systems for mobile devices. Introduction. Challenges. 01. We have developed a method to verify smartphone participants by integrating EEG data with the standard 3D pattern matching method. 02. Security attacks like pattern matching and shoulder surfing are prevented by using EEG signal-based authentication. 03. To assure the accuracy of our proposal we developed a new system based on the HMM comparisons to the more advanced support vector machine SVM. Have shown the system's reliability. 04. Our system's difficulties, portability and applicability to handheld devices like smartphones against different types of known attacks. 05. Personal authentication for smart device security methods such as text passwords, gesture patterns, PIN, SAND, traditional biometric information, fingerprints, iris recognition etc. are used to validate a user's identity. 12. Pattern recognition, shoulder surfing and the introduction of malicious code to perform dictionary attacks on passwords or PINs might compromise current security systems. Objectives. Objective 1. A comprehensive examination of the academic literature regarding authentication utilizing smartphone sensors was undertaken, resulting in a systematic review. Objective 2. To design and analyze EEG data based on the authentication approach. To design and analyze EEG data based on the authentication approach. Study map. 1. Systematic review. A comprehensive examination known as a systematic review is conducted to assess all available evidence on a particular research question. 2. Design a new authentication method. Develop a new approach for verifying the identity of users attempting to access a system. 3. Create an authentication application. Designing an application for authentication purposes in addition to creating a database of users. 4. Experiences. Carry out pilot evaluations on our recently developed validation system, which we designed. Authentication utilizing EEG based on a smartphone's 3D touchscreen. Our system simultaneously records EEG signals when users perform gesture-based unlocking operations.
Authentication utilizing EEG based on a smartphone's 3D touchscreen sensor mediated a statistical feature extraction. The mean, the median, and the standard deviation are the 3 statistical characteristics calculated from each processed signal. All the information provided is accurate. 1. The mean, M, feature reduces the effect of noise in the signals, leading to more reliable results. The calculation of this feature encompasses all time samples within the signal. 2. The median is a statistical measure representing a dataset's central tendency. It is determined by arranging all the data points in ascending or descending order and selecting the value in the middle. In cases with 2 middle numbers, the median is calculated as the average of those 2 numbers. 3. The standard deviation, SD, is a statistical measure utilized to determine the presence of B. Feature extraction of discrete Fourier transform. The discrete Fourier transform, DFT, is a widely recognized method numerous researchers use to process electroencephalogram (EEG) signals. This method, using an input signal, may be broken down into its component sinusoidal signals of varied frequencies. Before applying the DFT, a high-pass filter with a cutoff frequency of 0.16 Hz is used to eradicate noise from EEG data. A high-pass filter can eradicate low-frequency aberrations such as electrogalvanic and motion artifacts during signal collection. To ensure the signal is band-limited, a low-pass filter with a cutoff frequency equal to the greatest frequency of concern, in this instance 40 Hz, is utilized. The discrete Fourier transform, DFT, is utilized to decompose signals into distinct frequency ranges, including theta, 4 to 8 Hz, alpha, 9 to 12 Hz, beta 13 to 16 Hz, beta 17 to 25 Hz, and gamma, 26 to 40 Hz. The importance of gamma band wave variability. De-authentication of users presented with a set of identities and samples, abbreviated as identity, sample. The system should be able to identify the sample that provides the best possible match for the identity. This challenge is also known as the authentication issue or the verification problem. Simple techniques are used to attain this goal. The similarity between EEG signal samples from the same user is higher than between EEG signal samples from different users. Results and discussion 1. Collecting datasets. In this study, EEG signals were captured from 5 participants as they drew 3D patterns on their smartphones. 5 of these 10 participants were deemed to be legitimate users, while the remainder were deemed to be forgers. During recording, users were instructed to maintain a calm state. Since the duration of the nodes selected from the 3D pattern unlocking the results and discussion 2. Performance evaluation. The evaluation of the authentication system is conducted through widely recognized security metrics, including results and discussion 3. Authentication results. A 2-step process is used to compute the results of the authentication. To begin, the results were computed. Conclusion. 1. The present study introduces an authentication mechanism for smartphone with EEG signals. 2. The primary objective of this study is to examine the feasibility of generating comparable neural 3D patterns in an imposter by utilizing a specific user's identical 3 levels pattern. 3. This study obtained electroencephalogram EEG signals from a sample of 10 participants. In the end, thank you. Enjoy me.